Hi class, what we're going to do today is sort of a reverse calculation uh, using density as a formula. All right, we are going to be uh, supplying the densities to you, and here's a list of let's see, 1, 2, 3, 4, 5, 6, 7, 8 common metals. All right, I just looked these up on the internet. All right, and put these off to the side real quick. My question to you guys is going to be, let's say I had a cube of one of these metals, right? And I went ahead and I measured it, all right? Can you compute how much this thing weighs, or what the mass of this cube would be? All right. So what is the mass of this block if it were made out of, let's say, aluminum. All right. Now I cannot do this calculation unless or until I go ahead and get a measurement of the size of this cube. All right. And I measure the size of this cube. It measures at 3.192 centimeters. All right. So I have a cube here whose side is equal to 3.193 centimeters. Okay. Now, the way we're going to approach this is through a density formula. Right. If D is equal to M over V, and that is the correct density formula, then how do I compute mass out of this formula? All right. Now I do a little bit of, I'll go right ahead. Multiply both sides by V, simple algebra. It would cancel out on this side, and I would get mass alone. So mass on one side is equal to volume times density on the other side. So this is my mathematical avenue to answering this question of what is the mass of this block. All right. Now let me make a little room for myself here. All right. Notice in this formula, to find mass, I need density and I need volume. The density I'm going to get by looking it up based upon its identification of aluminum. Right? Aluminum has a density of 2.702 grams per cubic centimeter. So let me write that here. Right? The density of aluminum equals 2.702 grams per cubic centimeter. D for density, and I put a little AL underneath it to identify it as the density of aluminum. All right, makes sense? Okay. So I have the density part of this formula. All I need is the V. Where's the V coming from? The V is going to come from a calculation that we're going to do here based upon its geometry. I know it's a cube with the side equal to this length. What's the volume of a cube? It's side times side times side. right? If all the sides are the same, it was side cubed, in other words, right? Volume is equal to side cubed, which is equal to 3.193 centimeters, and that is cubed, right? That means it's multiplied by itself 3 times. You don't multiply it by 3. You multiply it by itself 3 times. All right, now getting my calculator out here. 3.193, and I'm going to cube that. When I cube that, I get an answer of 32.55343006. Now I don't want all those digits. How many digits do I want? Well, raising a number to a power is really multiplication, and the rules for multiplication are you want as many sig digs in your answer as you have in the numbers that you use to get your answer. The measurement of the side was 4 sig digs, so I want to pull 4 sig digs off of my calculator here. So I'm going to take 32.55, 32.55, and when I cube centimeters, I get centimeters cubed. How about that? All right. So I have now all the necessary information to get my mass. My mass, I need volume and I need density. For this little block, all right, I know it's made out of aluminum, so I go and I look up the density of aluminum. All right. The volume I could get based solely on its geometry. I know it's a cube. I could compute the volume. It's side cubed. Measure the side, cube it, and I get the volume, 32.55. All right. Again, let me make some room for myself here. So I'm just going to pull my formula up from here. This would be density times volume, or volume times density, doesn't really matter. So density is 2.702 grams per centimeter cubed. All right, I'll just throw that in parentheses. And the V is 32.55 centimeters cubed. Now, when I multiply those together, 2.702 multiplied by 32.55, I get 87.95. 87.95. Now, what are my units? All right, well, it's a mass, so it should be in grams. But if I go back up here to this step above, I see that the units here are grams over cubic centimeters, and then this is just cubic centimeters. Right? This unit of cubic centimeters cancels with this one. This is a cubic centimeter unit on bottom, and this is a cubic centimeter unit on top. And just like we could cancel out common factors in fractions, if one's on top, it could cancel with one's on bottom, we could do the same thing with units. So we're left with grams in our answer. So sort of a way of checking to make sure our arithmetic was done properly if our units cancel out. So according to our calculation here, this cube, if it were made out of aluminum, would weigh 87.95 grams. Okay. Let's see if we can't go ahead and change up this calculation just a little bit. let's say I were asked to approach this calculation from the other angle. Let's say I know the mass of my cube of aluminum. I'll stick with aluminum for right now. All right, let me go ahead and just real quick measure the mass of this guy. All right. I'm getting a mass of 5.52 grams. I've got my little cube of aluminum. All right. Mass equals 5.52 grams. All right. And the question now is, what is the volume of that cube? What is the volume of a 5.52 gram cube of aluminum? All right. Again, this actually is going to be a density problem of sorts. If D equals M over V, now I'm asked to solve for volume. How do I go about doing that? All right. Now, let's multiply both sides by V, and I'm going to get the same equation that I got before. Mass is equal to density times volume. And now go and divide both sides by D. Right? D's cancel on this side, and I get volume is equal to mass over density. Okay. So let's just plug into that formula. Okay. Volume is mass over density. Let me put that up here. Volume equals mass over density. Volume is equal to the mass, 5.52 grams, over the density. All right, the density is based upon our knowledge that it's made out of aluminum. You could look up the densities of common materials on the internet real easy. Just plug into Google, what is the density of aluminum? And it'll spit out that number for you. So anyway, I'm going to put that down here. 2.702 grams per cubic centimeter. All right. Now I'm going to grab my calculator. 5.52 divided by 2.702, and 5.52 divided by 2.702. All right, now I have 3 digits on top. I've got 4 digits on bottom. The rule for division is go with the least number of sig dig. So that's the top number is 3. So I'm going to round my answer to 3 digits. And here you'll see that is 2.04. 2.04. Now the question is what units do we have for volume? Well, volume is cubic centimeter units. And if I go back upstairs to this portion of the calculation, I see that my grams units cancel. I have 1 gram on top and 1 gram on bottom. Those would cancel, and I'm left with cubic centimeters only, and that's the unit that drops down into my answer. So the volume of this cube is 2.04 cubic centimeters. Right? Not a very big cube at all. All right, remember, cubic centimeters are the same as milliliters. So this is about 2 milliliters. That's not very much at all. All right, a milliliter is rather small.